What's up, y'all? Today we're going to be going over some basic terminology. I've got some problems regarding what's linear, what's first order, what's second order, what's homogeneous, stuff like that. So I'll go ahead and write out what a first order linear equation would look like, or just like an in order linear equation. So what you would have is you would have a sub 0 of t, some function with that involves the variable t multiplied by y to the power. This is not to the power. This is to the derivative. So the you can write derivatives like the second derivative of y is like this. That's not y squared. It does not equal y squared. What that equals is y double prime. So just a little, that's a notation, just so you're aware of that. It's very important not to get that confused here. So we have some function of t times y to the power of n. Well, then we're going to have after this, some second function of t, right? Some different function of t multiplied by y to the power of n minus, or to the derivative, I'm sorry. So it's such a habit to say power, but to the derivative, the derivative that's under this. So if n equals 2 here, this means that this is going to be y double prime, and this is going to be y prime, right? And they're both going to be multiplied by each a sub t. So, and the idea is, if it's linear, it's going to go all the way up until you get to just y, right? Well, what is the zeroth derivative? The zeroth derivative of y. The zeroth derivative of y is just y, right? You haven't taken the derivative of it. You haven't done anything. So basically, you're waiting. You're trying to get this. This n is going to go to 0, right? So you're going to be left with y, the zeroth derivative of y, and that's going to equal some function g of t, right? So this is what defines an equation being a linear differential equation. Now g of t could be any function of t, but if g of t equals 0, then the differential equation is what is called homogeneous. It's a homogeneous differential equation. The order is whatever the highest n, so the highest derivative of y. That's what's going to be the order of the differential equation. So if you were to have like y double prime plus 2y prime plus y equals 0, well, this is going to be a second order differential equation, and it's also going to be homogeneous, right? It is homogeneous because g of t equals 0 right here. It's second order because you have the highest power of the highest derivative of y is going to be the second derivative. So let's do some example problems. Got some for you. Okay, so our first one is going to be t squared. And this is just a Leibniz notation for the second derivative right here. Okay, so now if you'd like, you can rewrite it out of the Leibniz notation back to the, I guess, Newton notation. So you have t squared y double prime plus t y prime plus 2y equals sine of t, right? So we know that each term acts like a coefficient, kind of, right? It's a coefficient, but like with a variable in front of each descending order of y, right? So this would be a function of t times the second derivative of y. So the highest derivative is the second derivative, right? So this is a second order differential equation. We know that. So it is second order. Got that. We know that g of t does not equal 0. So this is going to be non-homogeneous. And it's also, we know that the orders of y are descending. It is linear. And you really want to determine linearity first in these kind of equations. I don't think that you have to be too specific on it if something is non-linear, if it's going to be homogeneous or not. So it's a second order differential equation because the highest order of derivative is the second derivative of y. It's linear because each has a function of t, even though you could still call g of t equal to 2, right? I mean, it's not, or not g of t, I'm sorry, some like a of t. Just because there's not a t in here, it could be a t or it could be just a coefficient. It doesn't even have to be 2. It could just be y. It would still be linear. What's important here are the y's. So second order linear, and it's non-homogeneous because g of t does not equal 0. If this equaled 0 right here, then it would be homogeneous. So let's try another one. Okay, so now if you'd like, we can rewrite it, right? So 1 plus y squared y double prime plus, just get a little bit better, plus t y prime plus y equals e to the power of t, right? So we do have a g of t. This is a function of t, right? So g of t equals e to the power of t. So it doesn't equal 0. So we'll leave that there for now. Right here we have, well, this is okay, right? Because it's some function of t, right, in front of a y prime, and then this is fine too, because technically it's just like 1 in front of that y, right? So it's still valid. These two are valid, but however this right here is not valid because you have a y where this should be in terms of t. Now if that were like a 1 plus t squared or something, then that would work out and it would be linear, but this is a non-linear differential equation. So it's non-linear, and the order is going to be 2 still. So second order, because the highest derivative is the second derivative. The highest order of derivative is the second derivative. So let's try another one. Okay, so now with this, you notice that each derivative of y doesn't have any coefficients, right? Any sort of t in front of it, but that's okay. As long as there's not like a y out in front. But if you notice, this is let's say y to the n is, or y to the nth derivative of y here is 4. It's the highest order, so we know that this is a fourth order differential equation, right? And then what we can also say is that g of t does not equal 0, so it is non-homogeneous. It's a little hard to read. Anyway, so now we just need to see if the orders of the derivatives are descending, right? And they are. This is the same thing as saying the fourth derivative of y plus the third derivative of y plus the second derivative of y plus the first derivative of y plus the 0th derivative of y, or just y itself, right? So they are descending. So that means that it is linear. So what you have is a fourth order linear non-homogeneous differential equation. So let's do a couple more. Let's see. Use this orange mark so you can see a little better. So here we have second derivative. Okay. So now let's just look first off at linearity. This term is going to be okay because second derivative, no coefficient, you should be good with that. This is where it gets weird because you have the sign of y, and it's not multiplied by just like y. So this would be nonlinear because of this y right here, because it has to be, remember, it has to be in the form a of t times y, right? And this does not look like that. This is like some function plus. This is like an embed function with y kind of. So this is going to be nonlinear, and the order is going to be second order. So we have a nonlinear second order differential equation. Second order because the highest derivative of y is the second derivative. So let's do one more. Okay. So let's look at linearity first, and we'll see if this differential equation is linear. So we have the third derivative of y right here, right? And there's not a coefficient attached to it. That's okay. So this is good. Here we only have the first derivative of y. We don't have the second derivative of y, which is okay. That's okay. That it can still be linear. It doesn't have to. Just because you have a missing derivative term in between doesn't mean that it's not linear. So this is going to be okay too, right? Because you have a term, you have some sort of like a of t, and then multiplied by the derivative of y. And then here is cosine squared of t, a function of t, some function of t. It is, isn't it? And it's also multiplied by y itself, right? Not a derivative of y. That's got to be the last one. y to the 0th derivative, or y, the 0th derivative of y is just going to be y. So linearity, it is linear. G of t does not equal 0, so it's going to be homogeneous, right? Or it's going to be non-homogeneous, I'm sorry. If G of t did equal 0, it would be homogeneous, but it doesn't. So we have the highest order is the third order, so we have a third order linear, non-homogeneous differential equation. So that's going to be all I'm going to do on terminology. It's really not that bad once you get the hang of once you get the hang of it, it'll just click and you'll get it really easily. I'll be back to do some verifying solutions of differential equations. So hope you enjoyed this video. Thanks.